Alright guys, welcome to another video. This one here is to perform the operations and write the answer in lowest terms. Assume all denominators are non-zero. So let's just get our brush out. Let's pick a nice little yellow color here. When you guys have questions and problems like this, your teacher's going to want you to make some sort of operation, whether it's a subtraction or an addition or multiplication, division, and they're going to give you a bunch of binomials and a bunch of trinomials. They're trying to confuse you. The easiest thing to do is let's just separate all these terms. Okay. And the trick here is they want you to factorize every single one before you do all these operations. It'll be a lot easier for you. So can we factor A anymore? No. Can we factor B? Yes, we can make it simpler. So let's take B. X squared minus 16. Well, they give you this, and if you guys can see that this is a perfect square. The square root of x squared is x, and the square root of 16 is 4. So this is a subtraction of two perfect squares. And when you guys see it's a subtraction of two perfect squares, you guys could write the factor as the perfect square, the square of this times the square like this, right? So the square root of x squared minus 16 is x minus 4 times x plus 4, right? So can we factor c anymore? C cannot be factored anymore, but we could factor D. D we could factor a little bit more. It's a trinomial, and of course we could factor it. So when you guys have a trinomial like this, and you guys see that the coefficient in front of x squared is 1, we could use the sum and product rule. So what is the sum and product rule to factor these? Well, the sum and product rule is pick any two numbers that the sum will give you 8, but the product will give you 16. So how do I know what two numbers? Well, let's see. What are the factors of 16? Well, 4 times 4 is 16. So if I do 4 plus 4, it gives me 8. If I do 4 times 4, that gives me 16. Aha. So these are my two factors. These right here are my two brackets. So we can do x plus 4 and x minus 4. Perfect, easy. So now we have everything factored. Let's rewrite this fraction over here. We'll put it over here. 2x over x minus 4 times x plus 4 minus 3 over x plus 4 times x plus 4. Okay, so we're almost there, guys. I'm going to shift this over to the next layer. I'm going to put this over here. We had 2x over x minus 4 times x plus 4 minus 3 over x plus 4 times x plus 4. Okay, so when we have a subtraction of two fractions, we want to use the common denominator. So what is the common denominator here? Well, this one here has an x plus 4 and an x plus 4. This has an x minus 4 and x plus 4. So what is this one missing that we could both add together? Well, this one here is missing an x plus 4, and this one here is missing an x minus 4. So we could put this in the common denominator. This one here is missing an x plus 4. So we can multiply top and bottom by x plus 4. So we're going to do this, x plus 4, and x plus 4. Similarly, what is this one missing? This one's missing, so it says x minus 4, x plus 4, x plus 4, x plus 4, and x plus 4. We're missing an x minus 4. So we could multiply top and bottom by x minus 4, x plus 4, and x plus 4. Cool. We're almost there. So let's expand this out, and then we have a common denominator. Let's expand this out. So we're going to bring this into your bracket. So that's going to become, that becomes 2x squared plus 8x minus, we're going to bring this one in, 3x. This becomes minus 12, but a negative times a negative plus 12, all over x minus 4, x plus 4 times x plus 4. We're almost there. This is pretty much a 9 on 10, but your teacher's going to want you to simplify, so you're going to have to group like terms. You see that right here. So your final answer would look something like this. Just get that common denominator in there, And there you have it. Perfect 10 on 10 on these tricky questions. But if you could break it down, factor everything, and do your operation at the end, you're going to get this final answer and you're going to get that 10 on 10. All right, guys. I'll see you guys in the next episode. See you there.